Nuclear fusion is when two atomic nuclei join together to make a nucleus. This releases energy. The Sun and other stars use nuclear fusion to release their energy. The sequence of nuclear fusion in stars is complex, but in general it is when hydrogen nuclei join together to form a helium nucleus. We can't use nuclear fusion in power stations on Earth because the required temperatures and pressures are so great we would need temperatures of about 100 million degrees. That would probably result in something like this.
American Fatso, your knowledge helped us build this plant. We would like you to have the honor of cutting the ceremonial ribbon.
I'll see myself out.
Stars have enough hydrogen to maintain their energy output for millions of years. During most of a star's lifetime, hydrogen nuclei form together to form helium nuclei. But as a star begins to run out of hydrogen, other fusion reactions take place, forming the nuclei of other elements. Heavier elements than hydrogen and helium, such as iron, are formed this way. Elements heavier than iron are formed in supernovas. Heavy elements are found in the Sun and our solar system, which suggests that our solar system was formed from the remains of earlier stars that exploded as supernovas. Stars follow one of two life paths. On the left of this diagram is a path that stars similar in size to our Sun would follow, and on the right, the path that bigger stars would follow. The stellar nebula. This is the protostar, composed of dust clouds. In this stage, the star is trying to achieve equilibrium between gravity, the pressure on the core, and the temperature. Next, the average star. After achieving equilibrium, the star begins burning up its supply of hydrogen and helium through the nuclear fusion. The red giant comes next. Loss of fuel in the core results in expansion by up to 1,000 times. Next along is a planetary nebula. The star has no energy left and begins losing layers and forms a complex structure. The final stage of this cycle is the white dwarf. This is a very dense star that is the end stage of an average star life. The other cycle goes from the stellar nebula to the massive star. These fundamental stars produce heavy metals that help regulate the accretion rates of normal stars. Their formation is still a great mystery. The next part of this cycle is the red supergiant. Biggest stars in the universe with short life cycles. Forms at the end of star life. Next, the supernova. A stellar explosion that is triggered by the loss of any remaining fuel, enriches interstellar medium. The supernova goes to one of two things. Either the neutron star, which is the remnant of supernova that ejects particles, or the black hole, infinite gravity and no mass.